In our previous video, we discussed the grounding requirements for alternating current systems, distinguishing between those that must be grounded and those that cannot be grounded according to section 250.20. In this video, we will further explore alternating current systems and circuits where grounding is optional, focusing specifically on alternating current systems of 50 volts to 1000 volts not required to be grounded, as outlined in section 250.21. Greetings, everyone, and welcome to the Codesultant channel. Today, we aim to deepen our understanding of grounding in alternating current systems beyond the corner grounded delta transformer connection. Our focus will be on exploring other alternating current systems and circuits where grounding is optional. According to section 250.21a, the following alternating current systems of 50 volts to 1000 volts shall be permitted to be grounded but shall not be required to be grounded. 1. Electrical systems used exclusively to supply industrial electric furnaces used for applications such as melting, refining, and tempering. In a grounded system, a ground fault is expected to generate enough current to activate the overcurrent device and protect the circuit. However, this fault clearing process interrupts the circuit, which may include a branch circuit supplying critical industrial equipment like furnaces. Since uninterrupted service is vital and downtime caused by ground faults is unacceptable, many industrial plants prefer to implement an ungrounded system. 2. Separately derived systems are used exclusively for rectifiers that supply only adjustable speed industrial drives. Examples of separately derived systems include transformers and generators connected through a 4-pole automatic transfer switch, ATS. In situations where this equipment is exclusively used for rectifiers that supply adjustable speed industrial drives, grounding is permitted but not mandatory. For the third alternating current system, 50 volts to 1000 volts shall be permitted to be grounded but shall not be required to be grounded as a separately derived system supplied by transformers that have a primary voltage rating of 1000 volts or less, provided that all the following conditions are met. A. The system is used exclusively for control circuits. B. The conditions of maintenance and supervision ensure that only qualified people service the installation. C. Continuity of control power is required. The illustration shows a motor control system, where a separately derived transformer with a primary voltage of 1000 volts or less provides power exclusively to a motor control circuits, as per condition B, if this system can only supervise and maintain the installation by qualified person and continuity of power is required for safety or operating reliability. Grounding for the system is optional. And for the fourth, there are other systems that are not required to be grounded in accordance with the requirements of 250.20b. Systems such as 120/240 volt, single phase under section 250.20b1, 3-wire, 208Y 120 volt, 3-phase, 4-wire under section 250.20b1 and b2, and 480Y 277 volt, 3-phase, 4-wire under section 250.20b2 and 3-phase, 4-wire, delta connected or high-leg delta under section 250.20b3, can be operated as ungrounded. A system that operates without a grounded conductor is not exempt from complying with Article 250 for equipment grounding and the required electrode grounding system. Industrial plants often prefer ungrounded systems over grounded systems due to their ability to provide continuous electrical operation and minimize system outage downtime. However, ungrounded systems do come with inherent risks such as fire hazards, electric shock, equipment damage, and interference. To address these risks in the event of a ground fault, certain measures can be implemented. According to section 250.21b, the installation of ground detectors is required in accordance with 250.21b1 and b2. But what exactly is a ground detector? A ground detector is a device designed to identify ground faults in ungrounded systems. In the ground detector lamp method, illustrated here, lamps are connected to the ungrounded 240 volt, 3-phase, 3-wire delta connected system to detect ground faults. Under normal conditions with no ground fault, all lamps receive the same voltage and appear equally bright. However, if a ground fault occurs on any phase, the lamp connected to that phase will dim or become dark, while the lamps connected to the ungrounded phases will become brighter. Let me explain how it works using an example. If a ground fault occurs in phase C, the voltage between phase C and point X will be 0 because point X is shorted to phase C. This is why the lamp connected to phase C appears dim or dark. On the other hand, the voltage between phase A and point X, as well as phase B and point X, remains at 240 volts, just like the voltage between those phases and point X. That's why the lamps connected to phases A and B appear brighter. What are the rules of the code for the ground detector? In section 250.21b1, 1. Ungrounded AC systems as permitted in 250.21a1 through a4, operating at not less than 120 volts and at 1000 volts or less shall have ground detectors installed on the system. In solidly grounded systems, the occurrence of a line-to-ground fault triggers the automatic opening of the circuit by the overcurrent protective device. However, in ungrounded systems, a line-to-ground fault causes the faulted circuit conductor to become grounded until the damaged conductor insulation can be repaired. It is important to note that if this ground fault goes undetected, it can pose a hazard. To address this potential hazard, ground detectors are installed in ungrounded systems to identify such faults. The installation of these detectors is crucial in order to promptly detect and address ground faults. In the event of a second insulation failure on a different ungrounded conductor, a line-to-ground fault may occur, which has the potential to cause more extensive damage to electrical equipment. Furthermore, in accordance with section 250.21c, it is required to connect the ground detection sensing equipment as close as possible to the point where the system receives its power supply. Additionally, ungrounded systems must be clearly marked in a legible manner. The marking should include the caution statement, "Caution, ungrounded system operating," followed by the specified voltage between conductors at the source or the first disconnecting means of the system. It is essential that the marking is durable enough to withstand the environmental conditions to which it will be exposed. In summary, section 250.21 pertains to alternating current systems ranging from 50 volts to less than 1000 volts that are not mandated to be grounded. If an ungrounded system is chosen, certain requirements must be met to ensure compliance. Specifically, ungrounded systems typically necessitate the installation of ground detection systems, as outlined in 250.21b. Additionally, the equipment used in these systems must be appropriately labeled, stating, "Caution, ungrounded system operating voltage between conductors," in accordance with 250.21c. Thank you all for watching.